Dear students, in this lecture, we shall learn about the structural form and the reduced form of equations that are used in economics. To understand it, we shall straight away come to an economic example to make it more quick. Now you can see that we have assumed two equations that are the equation of national income and the equation of consumption function at macroeconomic level. Now you see that these two functions and hence the equations explain the structure of an economy in a way that they explain how the national income is composed, the first equation. The second equation tells us that how people tend to consume their income and the increases in their income. So these are called as the structural equations because they explain the structure actually. You can see that Y is having its standard notation, C is also, whereas I is having this bar on it that basically shows the autonomous level of the variable, that is the autonomous investment. There is another alternative of writing the autonomous level, and that is by using a naught in the subscript of the variable. That is equally applicable. Now, as we can know that A and B are the variables that are the parameters, or in other words, these are the variables that are constant. You know, there are various definitions that actually explain that parameters can change to a certain extent and not to any level. So, a structural equation is an equation that is explaining the structure of the economy. Now, using these equations, we can reduce the equations to another form which is more representative and which is easy to calculate and then to interpret. We are going to do that, and as you know that we have two equations in this case, and there are at least two unknowns. So this makes it a system of equations, and they are the simultaneous equations because the number of unknowns are equal to the number of equations, and we can solve them. And in this case, we have adopted the way of putting the value of one variable into the other equation where it fits. And as you can see here, that in place of C, we have substituted the value of C from equation number 2. And we are simplifying it because Y is common here. So we have brought this term into the left-hand side and taking Y as a common factor. And the other term, which is, constant term here and there, they are left on the right-hand side of the equation. Now we need the value of Y, so we are shifting this term to the denominator. So we get the a simpler form of the value of the endogenous variable, because endogenous variables are the variables that we can find using the given information in the set of equations. A more simplified version of it is written here. It is more compact. We know that this is the exogenous variable here, right? And these are the various parameters and their expressions. Now, why we call it a reduced form equation? This is the question. Why? Because we have reduced the equation to a situation where the endogenous variable is in terms of the parameters and the exogenous variable. That is, Y is in terms of A, B, which are the parameters, and I bar, which is the exogenous variable. Once we achieve this situation, we can say that we have achieved the reduced form of the equation. Now this was the value of Y, that is the value of the first endogenous variable in the equation. Now we have another endogenous variable in that system, which was C. So we can find the value of C as well in order to interpret the whole system in a better way. You can see here we have to find the value of C, which has this function. Now we are putting the value, that is the value from the reduced form of Y, and this also becomes a certain point where we put the asterisk to show that this is the final result, which is showing the value of the endogenous variable. Now, using this notation here, we are putting the value of y, and once we do that, this is the whole value, and we have put it here. A is as it is, 8, plus, and the whole value, the value of y. Now, further, you can see that there is that simplification process that includes the LCM, which we have been doing since the beginning of mathematics and in our learning process. And as you can see, we have taken this LCM and we are simplifying it, which you can pause the video and you can do this easy process and verify if the answers are okay. After simplification, we get the value, that is the value of the endogenous variable, the second one, which is C, and this is the value of the consumption in its reduced form. As you know, once we have the symbolic results, we can put the numerical values in order to get the numerical values which are more interpretable. If we assume that the exogenous variable, that is I bar, is equal to 100, and the parameter A is 500, and the parameter B is 0.8, we can put these values in the value in that formula that we obtained for y asterisk and for the formula of C asterisk. Once we do that, we get the numerical value of the endogenous variable number 1, that is y, and if we put the values in the other equation, that is the value of C bar, we shall get the numerical result which is in front of us. So in this way, we can see that we can also get to the numerical values of the endogenous variables, and that is by reducing them from the structural equations.